This Late Night Linux Family podcast is made possible by our patrons. Go to latenightlinux.com/support for details of how you can join them. Support us on Patreon for access to ad-free episodes and early releases. That's latenightlinux.com/support. 2.5 Admins, episode 285. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. Before we get started, your customary Clara article plug, Alan, is ZFS in production, real-world deployment patterns and pitfalls.
Yeah, so in this one we talk about the different ways people deploy ZFS, whether that's for a file server or virtualization or backup and archives, and then some of the problems they run into, like common design pitfalls like not using the right type of VDEVs or just throwing more parity at it, and all the human factors that lead to data loss.
Okay, and another plug for your upcoming webinar.
Yes, so on February 18th at 11 a.m. Eastern, Clara will be hosting a webinar about Proxmox and ZFS, and include how to do GPU acceleration for the guests to do virtual desktops, and how to leverage ZFS fast dedupe for VMs.
Right, well, link to both of those in the show notes. Why has Microsoft been routing example.com traffic to a company in Japan?
One word, autodiscover, baby.
Who would have thought the little feature they designed, I don't know, would have been 25, 30 years ago, to try to guess the mail server for your ISP would make such a bloody mess.
Anybody with half a brain,
Yep.
even then, should have figured that out.
Yep.
So for the uninitiated, what is example.com?
Example.com is it's the Internet Engineering Task Force's version of Microsoft's Contoso.com. It's just a test domain that is only supposed to ever be used for, well, examples. You don't use it in production, you can't own it. There's an RFC 2606, which actually mandates that you can't register example.com. That's reserved. It shouldn't go anywhere. The problem here is that Microsoft's autodiscover protocol for Outlook, and this is not the first time this autodiscover protocol has leaked data to places it should not have gone. When example.com finds its way into people's systems and they start attempting to use it, autodiscover will append new top-level domains after example.com in the attempt to find a way to deliver mail to it that doesn't necessarily exist. Now, nobody, including Microsoft so far, has said they know exactly how the autodiscover protocol led specifically to traffic intended for example.com to wind up at this Japanese firm, SEI.com, but that is the route by which it happens. At some point when autodiscover starts appending new top-level domains after example.com, for example, example.com, .br or example.com.jp, at some point we're hitting something that is a defined domain, and one presumes either has a CNAME that points to SEI, or perhaps just has an A record which resolves to the same IP addresses that SEI.com uses. And unfortunately, because we're talking about an autodiscover issue, there may in fact be people's email passwords that are somehow winding up getting relayed out to this random Japanese semiconductor factory.
Yes, but it only happens if you're using the Outlook auto configuration feature, so it's not leaking random people's random email things, just the 30-some% of the internet that uses Outlook.
I guess if you're including all the home users, I mean, once you get into business, 30 seems real low.
Yeah.
Well, I've heard people correct email to, do you mean Gmail? So I think in the consumer space, Google's pretty much wrapped that one up.
But yeah, even like Jim's favorite client is a web-based thing, right? Where I guess Roundcube probably does actually use IMAP, but a lot of people's experience with email doesn't involve actually having to put in the information about their mail server, because it is kind of an ingrained service like Gmail or, Hotmail, which is not the same as Outlook, being that email is the service and it's not something the user has to configure.
Under the hood, Roundcube definitely does connect, IMAP and SMTP. It doesn't need to run on the same server as the actual MX, but probably surprising nobody, I usually run it, quote, hyperconverged, unquote. I just have the one, mail server in a bottle that's running postfix and Dovecot and the MySQL server that, contains all of the user authentication information and does the spam filtering and has a web server running Roundcube and postfix admin. It still does IMAP under the hood, but it's just, it's IMAP to localhost. And the nice thing is you can actually configure it so that by default, like the end user isn't going to have to know SMTP and IMAP configs. They're just going to log in with their email address and a password, just like they would at a Gmail or, Outlook Online or what have you. The biggest reason that I've migrated towards Roundcube being, my primary mail client is the search feature is just blisteringly fast. I have yet to find a local client, very much including Thunderbird. Even though Thunderbird is working with a local email corpus, the search is glacial. Whereas with Roundcube, if I want to find all the emails from a person, I can just type in a chunk of their first name and hit enter, and I'm instantly seeing a list of 100 emails or whatever. Whereas if I did the same thing on Thunderbird, it would be sitting and spinning for, anywhere from 30 seconds to 5 minutes before I saw anything. And if there are a lot of returns, they're going to show up one by one by one. Getting back to the original topic of the autodiscover protocol, I think it's probably worth pointing out that the major flaw in this idea of, well, let me try other things to make it easier for the user, is that it's appending things to a URL, not prepending them. If it was putting things to the beginning of the URL, it might or might not work, but it wouldn't be leaving the original domain, which is under the control of the original organization who you wanted those secrets to go to begin with. But because it's appending things to the end, it's absolutely going out of the control of the organization that it should have been going to begin with. So this was always a bloody stupid Johnson level idea the day that Microsoft implemented it. It never should have been done. It was incredibly stupid. And the fact that we're still using it nigh on 30 years later blows my mind.
Yeah, I don't know if 30 years ago it was a lot more prevalent to have unqualified email addresses, like that, where the domain didn't have any dots in it and they had to guess. I know a lot of internal networks kind of pre-internet and DNS just had @department or whatever and didn't have .com or whatever. But there's a lot of risk in appending instead of prepending.
Tony, who's a patron, wrote to us with a question. What are Jim and Alan's thoughts on the current wholesale migration to the cloud? Do the admins think businesses will eventually move back to on-prem hardware? What factors influence the decision?
I feel very qualified to address this one as the certified old guy in the room. I have seen this galloping transition from, and we say the cloud and local now, but historically speaking, overall, what we're really talking about is the move back and forth between distributed computing to centralized computing. And there are two general classes of factors that influence this: technical factors and human factors. Originally, we had centralized computing because computing was just too expensive. You couldn't put a real computer on everybody's desk. So you had one big computer, a mainframe or mini computer, and you had a whole bunch of dumb terminals that were not really computers at all. It's just a keyboard and a monitor connected, with a network cable, usually coax, God help you, to the mini computer or mainframe, off in the basement somewhere. And everybody's time sharing on the big iron somewhere else. That was essentially the only way to go at first, because there was no such thing as a microcomputer, right? They were expensive. With the rise of the microcomputer, that's when you started seeing a shift towards distributed computing. At first, sometimes the microcomputers just replaced the old VT100 dumb terminals for the most part. You were still doing most of your work on the big iron centrally. There are some human advantages to that. Even when you have local computing, well, your local computing is very likely going to require some local backup, system administration. Like, there's a lot of tasks that the person using, the end user at that microcomputer might not be very good at. And so it still is useful to say, okay, well, we're going to do most of our computing centralized, where our professional administrators can monitor it and manage it and back it up and make sure everything is good to go without having to go around and visit every single person's desk. So far, we're still basically talking about technical constraints. We're talking about, the economies of scale. There are also human factors, though. Once people started wanting to do more distributed computing, just using the local machine rather than, having to deal with the incredible sloth of VT100 over, like a 10 meg coax line, when sometimes you can literally buffer up paragraphs of text before you see them echoed back on your screen, it became really attractive to say, I could just run Lotus 123 on this actual IBM PC. And, it's more powerful, it's faster, it's better in like every way. But the thing is, the centralized control disappears when the centralized computing does. Yes, you can do all these things locally on your own machine, but now the overall organization has a lot less control over what you're doing. There's a lot more things to try to monitor. So, even above and beyond the economy, there becomes this real resistance to I don't want you to get your hands on this thing where you might mess it up. Or also even just, I want to make sure I have access to all your data. I want to see what you're doing. And it's a lot easier to see what everybody's doing if it all has to go through that central choke point. So that was the initial transition from centralized computing to distributed. But then with the rise of the internet, we immediately began seeing some shift back towards centralized computing. And basically, the longer the internet went on, the more we had this shift to the cloud, which is really just another way of saying we're centralizing things. We're putting it under centralized control. All the data goes through one choke point where we can manage it. Maybe we can back it up. Maybe we can snoop on it. Maybe we can train AI with it. But the point is, we're in control of it. And there's a pitch for the economy of scale as well. There's a pitch for saying, well, if you just put it in the cloud, you don't have to have these expensive admins that you have to manage locally because we'll do all that for you. We have more people. We have the best people, the bigliest everything. Just use our stuff and everything's good.
Yeah, and pay us $10 a month per head. It'll be fine, or $20 or whatever.
Exactly. And to be fair, that also frequently gets pitched as an actual economy because although you pay a hell of a lot more at that $10 per month per head forever, what you discover when you do my job, when you're an IT consultant, you're working closely with businesses and you're actually getting an insight into how they think and how they budget things, you discover that a lot of businesses are much happier about huge amounts of operational expenses than tiny amounts of capital expenses. Because a capital expense is difficult to predict. It comes in irregularly and you have to have spare capital on hand to address it when it comes up. You got to plan for it, all this kind of stuff. On the other hand, an operational expense is the same amount of money every month. And what that means is you're effectively not going to pay it at all because it's such a predictable expense. You say, this is part of the cost of doing business, and you pass that down to your customers. So as far as you're concerned, OpEx is just pass through, whereas CapEx, that comes out of your pocket.
Well, it's exactly the same with revenue coming in. That's why they want you on subscription services.
Yes, but also you really should not underestimate that reluctance to spend CapEx when you could instead spend twice as much OpEx, but it's just a steady drain that you can pass directly through to somebody else. That is a huge factor. At any rate, right now we're kind of at the peak to this very forced shift back to centralized computing, whether anybody likes it or not. And we're getting railroaded into it because, again, it's very useful. Centralized computing lets companies see your data, manage your data, get control of everything, impose much more difficult to escape vendor lock-in. This is all very much to the benefit of the people who control that centralized computing. Now, as to the second part of the question, is it ever coming back? Yes, this cycle is never going to stop. This is human nature. We're going to continue to see a shift between these opposite poles, which basically come down to maximum economy and ability and everything else for the end user, but the end user has to manage more versus centralized, which is tremendously to the benefit of whoever's providing the service. But it's never going to stick on either pole because each side does have different advantages for different sides of the war game, if you will. I'm already starting to see some shift back to on-premises computing, to local stuff, because even while I see a lot of organizations, especially multi-regional nonprofits, I see are just stampeding towards full-on everything goes into OneDrive, get rid of all the local file servers, get rid of all the local domain controllers. Everything goes in the cloud, let Microsoft manage it. I've been seeing a huge surge in that. But you know what else I've been seeing a huge surge in? Some of those exact same entities losing entire OneDrives due to it getting corrupted on the cloud end, not the local end, being completely unrecoverable when they reach out to Microsoft support and beginning to ask consultants like me, hey, how can I get local backups of this? Because this really hurts when it happens, and Microsoft isn't helping us.
Yeah, I think there's some other bits to this as well. Especially if you're, starting a new company or something, and you're looking down the barrel of, buying this server is going to be $20,000, or we can pay $100 a month to rent something like it. And sometimes that makes more sense in the short term, even if it's, $1,000 a month for that server. And, in less than 2 years, it would have been cheaper to buy the hardware one. But for the first 2 years, you didn't have that money. And so, being able to have that option can be quite useful, especially knowing that you can turn it off at any time. But at the same time, that elasticity of the cloud is, one of the big selling points. But if you aren't actually going to be able to take advantage of that or to use that, or your load is constant, not spiky, then it may not be a right fit. But one of the other big things that's been a draw, more of the cloud native apps and so on, is just the fact that setting up a new server is not like it used to be, where it was just an occasional thing the system is taken care of. At this point, it can be, something that happens multiple times a day and then a bunch of them go away, where it's all about kind of orchestrating VMs and containers and so on. And that type of thing, while still being the cloud, doesn't necessarily have to be done on somebody else's cloud. A lot of places are doing basically a local private cloud. So they have their own servers in racks at the office or whatever, but they have the cloud layer in there. That means that they have, similar APIs to be able to just stand up and stand down VMs, and basically allows the IT department to multi-tenant and sell access to pieces of those machines to the different departments as if they were a cloud vendor, but without, and it gives you that hybrid. But I think, are we going to see things going backwards? I think yes. One of the big ones is, in Europe, we're seeing a lot of places worrying about sovereignty, right? They're like, we don't want our data living in US data centers now. So our choices are put it in our own cloud where we definitely know where it is, or maybe somebody will make a decent EU cloud and maybe we can use it and maybe it'll be okay, but when will that happen, and so on. And so you see a lot of places pulling back. But also a lot of places were just looking at, the cloud said it was going to be cheaper. Maybe it was when we were a startup and we were scaling, but we're now at a steady state where we have at least some load that we're always going to have, and buying hardware and putting that in a data center is going to be 2 to 4 times cheaper than continuing to pay for the cloud for that. And so, yeah, we've seen a lot of people move back. And sometimes when they do, they're looking to not go back to just plain separate servers, but to have basically a local version of the cloud, because some of those orchestration and the tooling around it is still useful, even if it means, you're still using it on your own iron, not somebody else's computer.
I might even argue that even on a very, very small scale where there's, only one production hardware server and, maybe an on-site hot spare server and an off-site disaster recovery server, it's already really a local cloud, because you're not doing things with an operating system directly on the bare metal. Everybody these days pretty much is running VMs on the hardware. And when you're at the point where you have a certain amount of hardware, but the number of operating systems you can have running concurrently on it is not tied directly to the pieces of hardware that you have, you're already cloud, in my opinion, at that point. You can already ask the IT department, hey, can we have another VM for this thing? And they can spin that up real quick for you.
See, I think that's where I would draw the difference. The cloud workload is a bit more where instead of you or the IT department going in and, clicking around in a GUI and making a new VM, is, an application is making an API call and setting it up for you. And it's really, oftentimes it comes from a dysfunction of an IT department that a company wants people to be able to do stuff without having to talk to IT or making a ticket in order to get that new VM. They Terraform or whatever, run a command, and some magic happens and some config files fly around and a VM gets created. And it's definitely a problem I've seen in other places where all of this seems to be just trying to work around the fact that, this department and the IT department were not getting along. And that's why we built this whole complicated system.
I don't see a whole lot of what you're describing. I know it exists out there, but the thing is, you can say, oh, well, just an API and whiz-bang and a couple scripts fly around, but in actual practice, anybody competent to operate that is competent to be in an IT department, whether that's the department they're working in or not.
I don't know. I've seen some developers try to be sysadmins, and that's not pretty.
Sure, but I've also seen plenty of IT departments staffed almost entirely with developers, and I'm not going to say good things about how those departments run, but they're still IT departments.
True.
You're drawing a distinction between IT and dev that I think a lot of listeners aren't necessarily going to, because what I've really been talking about is not IT versus developers. I'm talking about professional computer users versus people who have a job to do that they have to use a computer as a tool along the way. Whether you're a sysadmin or you're a dev, like your primary thing is dicking around with the machine for the machine's sake. Whereas if you're an end user, you're trying to accomplish a real world task using the tools that both dev and admin have to collaborate in some way or another in order to provide to you.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And if you want to send in your questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Kat writes, I want to create a ZFS pool with inexpensive large consumer SATA drives, for example Seagate Ironwolf. I can connect them via an older LSI adapter flashed to IT mode, HBA mode, or I can connect them using inexpensive NVMe to SATA adapters, like this one which Kat linked on Amazon. My thinking is that there should be no difference, since I won't benefit from the faster LSI chip like I would if I used the LSI as a RAID controller instead of just an HBA.
That's not how that works.
This is a fun one. We have some minor conceptual errors here. The thing that theoretically makes a RAID controller faster when it's used as a hardware RAID controller rather than as a simple host bus adapter, it doesn't have anything to do with a fast chip. It has to do with RAM on board the card and the card doing its own caching before it ever reaches the host operating system. This is not really that useful in this day and age, honestly. It can present issues. Having caching at the controller like that can cause latency spikes sometimes because, remember, caching means you're hanging on to the data longer. You can also wind up with reliability issues. You need to make sure you manage that cache separately. More importantly, it just doesn't actually accelerate anything significantly in this day and age. Modern RAM is every bit as fast as the DRAM that you're going to find on even a brand new RAID controller, much less, one from 15 years ago.
Well, and nowadays, each drive usually has as much cache as the controller would have.
Exactly. And on top of that, the host system has dramatically more RAM available for caching as compared to what you'll find on a controller. So the idea of it being faster in RAID mode, not really. So what this brings us back to is, am I better off with a proper LSI host bus adapter, or can I get the same effect by just using an NVMe to SATA dongle? Which in theory, they're doing the same thing, right? You're trying to bridge to the PCI Express bus and get a more rapid connection than you could going through a SATA controller.
Now, to be clear, what we're talking about is an M.2. It looks like one of those gumstick NVMe drives, but it's got 6 SATA ports on it?
Correct. Although it really doesn't matter what the interface is. Even if it was U.2, that wouldn't change anything. It's a dongle that bridges from NVMe to SATA. And what's really going to drive the performance of that device is how many PCI Express lanes does it support. Now, this particular NVMe to SATA dongle only supports 2 PCI Express lanes, whereas the LSI host bus adapters support 8. So typically, I would expect these inexpensive little 2-lane NVMe dongles. Now, I don't have direct experience with them, but I would expect them to perform about the same as a regular motherboard SATA controller would. They might possibly perform a little bit better because a lot of motherboard SATA is single lane instead of dual lane, but I don't know. I don't think they will really do much of any better. Alan, what do you think?
I definitely think the LSI will be better there.
No, I just meant, do you think it will even outperform motherboard SATA? Because I don't think it will.
Probably not. Although my experience with motherboard SATA has been so hit or miss. On one of my previous boards, the last NAS I built that didn't have an LSI controller, so it's quite a few years ago now, had like a 6 or 8 SATA ports that were on an Intel controller, and then 2 more that were on a separate Gigabyte controller, and then 2 more that were on yet another separate controller. So I had 2 groups of 2 and then 1 group of 6 or 8. And I thought, well, if I spread the drives out across those different controllers, I should get more bandwidth because each one's going to be connected to separate PCIe lanes or something. But the Gigabyte ones were so much worse, it was faster to connect them all to the Intel controller. And so, yeah, knowing what that basically unbranded SATA adapter thingy is going to be, I don't expect it to be very good.
It's not just performance that you've got to worry about, it's reliability as well. Because Gary, who's been on this show before, he's on Hybrid Cloud Show and Linux After Dark, he had one of these in a box. I don't know if it was this particular one, but it was, fairly cheap, like 20-ish pounds or whatever. And it worked fine for a while. Then he started getting loads of weird ZFS errors. He thought, oh no, my drives are on the way out. And then he thought, maybe it's that adapter. Sure enough, he tried those drives without the adapter and it was fine. So I would not put one of those in one of my machines.
I agree completely, Joe. I wouldn't put one in any machine of mine either, which honestly I think was kind of implied by me admitting I have zero personal practical experience with this, because just looking at it, I'm instantly recoiling in horror. I actually had to do a fair amount of research to make sure that I got the answers right, about how many PCI Express lanes. And, I even looked up like a typical motherboard SATA controller chipset. What was it? J-Micron JMB63 to make sure that I was getting all of that exactly correct. And the J-Micron is it's a single lane controller. I have certainly seen dual lane controllers, especially on, server grade motherboard or even workstation grade motherboards. But in general, the absolute best case scenario for the weird little M.2 dongle is it might be a little bit faster than motherboard SATA, maybe. In real life, I wouldn't expect it to be any faster. And yeah, it's weird. It's hinky. If you want to bridge SATA to PCI Express, there are tools for that. They're called SATA controller cards, and you plug them directly into a PCI Express slot. And to be clear, you can get cheap SATA controllers, and I would rather have an inexpensive dual lane SATA controller plugged directly into a PCIe slot on my motherboard than the weird little M.2 dongle.
Well, I've got exactly that in my offsite backup box, and so far, so good. No problems.
Oh yeah, I've deployed tons of inexpensive discrete SATA controllers. I've got plenty of practical experience with those. And generally an inexpensive, like an under $50 brand new SATA controller that plugs into PCI Express, it's not going to perform any better than decent motherboard SATA. It's also not going to perform any worse. And yeah, I have not had reliability issues with those.
Well, I'm pushing it up over 100 megabit uplink, so I'm not really bothered about performance. It's reliability I care about, and even a cheap one has been reliable, whereas I've heard this horror story about the M.2 one.
I don't even like the reliability of actual M.2 drives, let alone, let me see here. What is the brand here? Sunguyu. Or it's probably Sunguyu. I don't know. Whatever the heck it is. I mean, it is clearly the cheapest, zero effort, how can we just get somebody to hand us $20 for this thing sort of a product? And that's not what you want in between you and your hard drives.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me at joerest.com/mastodon.
You can find me at mercenariesysadmin.com.
And I'm at Alan Jude.
We'll see you next week.